Hello, in this video we discuss a new firmware option for our AWGs, Arbitrary Waveform Generators, the DDS mode, which is the short form for Direct Digital Synthesis. Normally, to get the desired waveform, you need to pre-calculate all the data in software and send it to the AWG, which then generates the analog waveform at the output. In this way, nearly every waveform is possible. But as one sample of data is needed for each output clock cycle, a massive stream of data is generally needed. If you just want to work with sine waveforms, the new DDS firmware option offers a much easier way. In DDS mode, you only have to set the desired frequency, amplitude and phase once to get a continuous sine wave output. New data is only necessary if you want to change the output signal. Up to 20 accumulated sine waves can be generated for one single AWG output. This means instead of needing gigabytes of AWG data, you only need a handful of DDS commands. Let's look at an example. For one endless sine wave, just 2 commands are necessary in your C++ programming. Just program an amplitude of 90% and a frequency of 100 MHz, and the result can be seen on the scope. Looking at the spectrum analyzer, the frequency of the sine wave is shown with low jitter, low distortion and low spurs. Additionally to the C++ API, the DDS mode supports a new high-level Python API, offering the same easy way to input the amplitude and frequency of the sine wave. Let's look at a multi-carrier example. Up to 20 sine waves, or cores or carriers, can be superimposed on one single AWG output channel, or, if needed, they can be spread among the different channels of the AWG product. Up to 23 carriers can be distributed on the 4 channels of an AWG card, and a maximum of 138 carriers can be spread among the 24 channels of the largest AWG generator netbox. In this example, we are generating 16 sine waves on one AWG output. They all have 5% amplitude, and the frequencies go from 100 MHz onwards in steps of 20 MHz, leading to frequencies of 120, 140, 160, and so on. The scope shows the resulting waveform of the 16 superimposed sine waves. The spectrum analyzer shows the 16 frequencies. Changing the DDS settings is very easy. You can update all the settings like frequency, amplitude and phase during runtime or using preloaded sequences of DDS commands. The updates can be triggered on external triggering, an internal timer, or immediately on command. No transition jitter or glitch appears, and the timing resolution is as small as 6.4 nanoseconds. A lot of sequences of DDS commands can be timed to occur sequentially, one after each other. They are FIFO buffered using gigabytes of onboard memory, so there is no problem to preload billions of commands if you like. It is possible to program linear changes of frequencies or amplitudes with only one simple command. Here is an example. We will shift the frequency for one of the carriers by 100 MHz from 20 to 120 MHz within 10 seconds. Just set the duration to 10 seconds and the slope speed to 10 MHz per second. All commands, like lowering the amplitude in the green block, can be pushed into the FIFO queue at any time, right before the next trigger event. With the new DDS option, very complex frequency constellations can be generated by using high-speed streaming and frequency multiplexing. This is needed for quantum computing and driving of AOMs, acousto-optic modulators. In this example, 20 sine wave carriers are frequency shifted to guide laser beams for catching and holding the atoms inside a quantum computer, and allow the atoms to perform the calculation process. Other applications can be found in communication systems where fast adaptive changes for frequency or phase are required. The DDS firmware option can be currently loaded into 23 different AWGs. These are PCIe and PXIe cards and LXI Ethernet units for mobile and rack use. Models offer 16-bit resolution and a sampling rate of up to 1.25 gigasamples per second.